Okay, now we're going to do some ellipse problems where we're not given the standard form, but we're actually given information about the ellipse, and then we're asked to find the equation. So this says, find the standard form of the equation for an ellipse centered at the origin with a horizontal major axis of 16 units and a minor axis of 10 units. Okay, so each of these pieces of information are going to help us. Now, centered at the origin and horizontal major axis tells us that we want an equation of the form x squared over a squared plus y squared over b squared equals 1. Now, to fill this in, we need to find a and b. Now remember that the major axis has length 2 times a. Well, we're told that that's 16. So we can then divide both sides by 2 and we get a equals 8. So that gives us right here, we're going to plug in, we'll have 8 squared there. Now we know our minor axis always has length 2 times b, and we're told that's 10, so b must be 5. So we're going to plug in 5 squared here. So that tells us that the equation of the ellipse that we're looking for is x squared over 64 plus y squared over 25 equals 1. And that gives us what we're looking for. Okay, let's do one more. Okay, so this says, write the general equation of an ellipse whose vertices are at 7, -2 and -3, -2, and whose foci are at 4, -2, 0, -2. Now the first thing I like to do here is kind of sketch out what we're given. So let's draw ourselves a set of axes. Okay, so our vertices are at 7, -2, and -3, -2. Now, since our vertices are horizontal from each other, that tells us that we're going to have a horizontal ellipse. Now, we can see it's not going to be centered at the origin, so we know that this will be of the form x minus h squared over a squared plus y minus k squared over b squared equals 1. So to find our center, the center is the midpoint of the vertices. Now remember, we knew the midpoint formula, so this would be like our x1, y1, x2, y2. So we take 7 plus -3 over 2, and -2 plus -2 over 2. So this would give us 2, -2. So this is our h, and this is our k. So we have our h and our k. We have this. We have this. We now need a and b. Now remember, a, I want to look for a, is the length between the center and a vertex. Okay, so between, if this is the point 2, -2, and this is the point 7, -2, we can see that that's a distance of 5. You could also use the distance formula, but here it's pretty easy just to see that it's 5. And so for A, we're going to plug in 5. Okay, the last thing we need is B. Well, the other information that we're given is about the foci. So we're told that the foci are at 4, -2, and at 0, -2. Now that doesn't give us B, but remember that the distance between the center and a foci, that's always C. So if this is the point 2, -2, and this is the point 4, -2, we see that that's a distance of 2. So we now know that C equals 2. And this is what we're going to use to find B. So we still have the formula C squared equals A squared minus B squared. So we'd have 4 equals 25 minus B squared. So if we subtracted 25 from both sides, we'd have -21 equals -B squared. We can multiply both sides by -1, so 21 equals B squared. So B is going to be the square root of 21. So plugging this all into our equation, we're going to have x minus 2, we have our h, squared over 5 squared, plus y minus a -2 squared over the square root of 21 squared equals 1. And to clean this up just a little bit, we can write this as x minus 2 squared over 25 plus y plus 2 squared over 21 equals 1. Okay, so just by knowing the vertices and the foci, we were able to find the equation of our ellipse.